This is Anita Wood, and welcome to this topic snippet video, which introduces us to a need in the real-world programming environments: version control. In the previous topic snippet on DevOps, we discussed three important components of the organization DevOps, or development operations. They were software methodology, team collaboration and communication, and this one, development platforms and tools. Software development teams work best when they have the right tools to help them focus on innovation rather than maintaining integrations and manually completing tedious tasks. Tools that help teams should include automation. Integrating automation into the workflow decreases the likelihood of human error and the amount of time spent on mundane tasks that pull the developer's focus away from delivering business and customer value. Project management. This feature helps teams plan releases, help increase visibility, keep track of the projects, and identify stakeholders. Finally, revision control. Current software development teams are made up of several individuals assigned to all work on the project simultaneously. Many times they're working on parts of the code that are mutually exclusive of each other, meaning they have nothing to do with each other. Other times they're working on the same feature that is focused on the same code block. The synchronization necessary for these developers to work independently yet together is resolved by using a tool that provides revision control. This feature is the focus of this topic snippet. People have to be able to work on the same file at the same time. Yet we're all on our own machines, in our own office, and many times in different time zones. Now, there are a few methods that were previously used to mitigate this issue. Not great methods, mind you, but they worked for the most part. First was placing the file on a portable device, such as a floppy, and use the sneaker delivery between the people working on the file. Only one file was allowed to be considered the floppy with the latest version. Now, there were many backups of the file around that contained older versions of the software. The sneaker delivery mandated the developers were within walking distance of each other. Once computers were networked together, another method was used. The project had a shared folder where the files resided. Everyone working on the project could access the files as needed, but the files weren't able to be edited on the system where they resided. Everyone had to download it to their machine to make any changes. They then uploaded it back to the folder with their changes. There was very little control over the downloading and the uploading of the file. For instance, I came in at 8 a.m. and downloaded the file to work on. Jim came in at 8:30 and downloaded the file to also work on it. Before the lunchtime, I uploaded the file with my changes to the folder. I probably felt pretty good about my progress I made towards the project and went off to lunch. Jim also uploaded the file he had been working on before he left for lunch. His changes were mainly on a different part of the code than mine. So Jim and I weren't working on the same areas of the code. But that really doesn't matter, because after lunch, I downloaded the file again to continue working to find none of my changes were present. An entire morning of work went out the window as soon as Jim uploaded his file, thus overwriting the file I had uploaded. To help eliminate the fact that files could be downloaded and then uploaded by anyone on the team at any time, teams set up a communication channel to signal when the file was downloaded and being worked on. We called this checkout. We would have a text file in the folder that people used to record when they downloaded a file. So everyone would check that file to see if anyone had a copy on the machine and was working on it. Thus, they should not download until that person uploaded the file and updated the text file. The process was only as good as the ability of the people to remember the process. Eventually, you could purchase applications that provided a check-in, check-out system for files. It registered when people downloaded a file and locked the file so no more downloads could occur. Once the file was checked back in by uploading it, the file was then unlocked and made available to check out. It was a bit better, but there was no more overwriting of the code, but the development process still was really slow. Only one person could have the file checked out at a time, and people were always getting in trouble because they weren't timely in getting the file uploaded or updating the text file. Version control was introduced to help solve the issues I just described. We were doing a version control light when we used the text file to record checkouts and check-ins. Today's version control does the following though. It enables multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. Thus, temporary or partial edits by one person didn't interfere with another person's work. Version control also enables one person, you, to use multiple computers to work on a project. So it's valuable even if you're working by yourself. Version control integrates work done simultaneously by different team members. In most cases, edits to different files or even the same file can be combined without losing any work. Now, there are rare cases when two people make conflicting edits to the same line in a file. Then the version control system requests human assistance in deciding what to do. Version control gives access to historical versions of your project. This is insurance against computer crashes or data losses. If you make a mistake, you can also roll back to a previous version. You can reproduce and understand a bug report on a previous version of your software. You can also undo specific edits without losing all the work that was done in the meanwhile. For any part of a file, you can determine when, why, and by whom it was ever edited. Remember, version control was developed to save all the changes in a repository. Hence, if the developers make a mistake, they can undo it. At the same time, they can compare the new code with the previous versions to resolve their grievances. This can reduce human errors and unintended consequences really to a great extent. Understanding the terminology that surrounds version control is half the battle in understanding how version control works. So we're going to start with a vocabulary lesson. We have a repository, sometimes referred to as repo, and that's the database storing the files. Now there is a server, which is the computer that is storing the repo. Then we have clients. And those are the computers that are connecting to the repos. Those are all the different software developers' computers themselves. They're the clients. We have a working set or working copy. That is what's on your local directory of files where you're making the changes. So each software developer has a working set or a working copy of whatever it is they have checked out. Finally, there's trunk or main. This is the primary location for the code in the repo. Think of the code as a family tree. The trunk is the main line. We're going to see a little bit more about that with images in a minute. I know you were hoping the vocabulary was located only on that one slide. Not to be. These terms are used to describe the actions that occur in version control systems. You have an add, which means you put the file back in the repo for the very first time. And once you do that, now version control is started. You have a revision. Now, after you add, you can keep making revisions and placing those in the repo, and they are being tracked. So you have versions 1, version 2, and version 3 after the initial add. Now I can check out, which means I'm going to download a file from the repo to my client to my working location. I'm going to check in. Now I'm uploading the file from my own computer back into the repository if it's been changed. If it hasn't, there's no reason to do it. So when I do that, you're going to get a new revision number and people can check out the latest one. You have a change log or history. That's the list of all the changes made to a file since it was created. It's more extensive than just the number version 1, version 2. It is the true listing of changes. Now, I can update or sync. So say I'm working on my own computer and I want to make sure that I have the latest version. And I want to make sure I have added my information to the versions up in the repo so I can synchronize the files. All right, so I know that I'm always working with the latest versions on my computer, on my client. And a revert is I'm going to throw away everything I did locally and I'm going to get the latest version back down. So I was playing and I'm saying to myself, this isn't going very well. This is going down a bad path. I want to start again. So I revert, but it's only going to be reversions on my local client machine. So let's look at some of those actions and put them inside of an image or a better representation. And I'm going to use betterexplained.com's website. And the website I'm using is the Visual Guide to Version Control because its images are really spot on for describing the general processes within version control to the level of understanding that we need. So check in. Here's a basic check in. Each time I'm going to check in a new version, I get a new revision. Revision 1, Revision 2, Revision 3, Revision 4. Okay, the very first time I put something up, I get that is called an add. Now notice the blue line is the main trunk. That is the process or where all of this work is being accomplished. And you can see it's along a trunk. So there's a better representation of trunk. Now in reality, you might not keep checking in a file. You may have to check out, edit, and then check back in. So the cycle looks like this. If you don't like your changes and you want to start over, remember you can revert to a previous version and start again, or just even stop. But when I'm checking out, I'm going to get the latest version by default. If I want to, I can specify some other version if I want. I don't have to get the latest. I can say I want to go all the way back to version 1 for whatever reason. Now, something called diffs. The trunk has a history of the changes as the file evolves. Diffs are the changes you made while editing. So imagine you can peel them off and apply them to a file. For example, to go from revision 1 to revision 2, we added eggs. So you can see the diff was plus eggs. Imagine peeling off that red sticker and placing it on revision 1 to get to revision 2. Now, to get to revision 2 to revision 3, we're going to add juice plus juice. To get to revision 3 to 4, we remove juice and add soup. So notice the minus juice and the plus soup. All of those things that are in the pink are the diffs, okay? Most version control systems store diffs rather than full copies of the file. That eliminates huge redundancy and also allows us to just end up dealing with those changes. So we save disk space. 4 revisions of a file doesn't mean we have 4 copies. We only have 1 copy and 4 small diffs. Pretty nifty, huh? So diffs help us notice changes. How did you fix that bug again? And even apply them to another branch, from one branch to another. We'll see branches in just a minute. So notice how juice wasn't even involved. The direct jump from R1 to R4 doesn't need that change since juice was overridden by soup. Branches. Promised it was coming. It lets us copy code into a separate folder so we can monkey around with it separately and not impact the trunk, any of the revisions. I have something I want to think about and I want to play. So we can create a branch for new experimental ideas for our list. Crazy things like rice or Eggo waffles. Depending on the version control system, creating a branch or a copy may change the revision number. But now that we have the branch, we can change our code and work out the kinks. Waffles. I don't know what the boss will think. Rice is a cipher bet. So since we're in a separate branch, we can make changes and test in isolation, knowing our changes aren't going to hurt anyone and nobody knows I'm over here. Even when they sync, they don't see me. So our branch history is under version control. Branching isn't too tough of a concept. Pretend you copied your code into a different directory. You've probably branched your code in school projects, making sure you have a fail-safe version you can return to if things blow up. Branching sounds simple, right? Well, it's not. Figuring out how to merge changes from one branch to another can be tricky. Let's say we want to get the rice feature from our experimental branch into the main line or trunk. How do we do it? Diff for R6 and R7 and apply that to the main line? No, we only want to apply the changes that happened in the branch, which means diff R5 and R6 and apply that to the main trunk. If we diffed R6 and R7, we would lose bread feature that was in the main. This is a subtle point. So imagine peeling off the changes from the experimental branch plus rice and adding it to main. Main will now have all the other changes, which is okay. We just wanted to insert the rice feature. So all we do is peel off the diffs when we merge. Many times in the version control system, it can automatically merge changes to different parts of a file, okay? And conflicts can arise when changes appear to not gel. Joe wants to remove eggs and replace it with cheese. So the diff is minus eggs and plus cheese. And Sue wants to replace the eggs with the hot dog. So they do minus eggs plus hot dog. At this point, it's a race. If Joe checks in first, that's the change that goes through. So Sue can't make her change. When changes overlap or contradict like this, the version control system is going to report a conflict and not let you check in. It's up to you to check in a newer version that resolves this dilemma. So you have a couple approaches. Reapply my changes. So I can sync to the latest version and reapply my changes to the file. So I can go and get Joe, if I'm Sue, and then add the hot dog to the list that already has the cheese. Or I can override the changes with mine. So I can say, sorry, Joe, you're not getting cheese. So I would check out the latest version, R4, copy over my version, check my version in effect, this removes cheese and replaces it with hot dog. Now, these conflicts are infrequent, but they can be a pain. But ultimately, what happens is the requirement of human intervention makes sure it doesn't go awry. Now that you have an understanding of version control, specifically why we need it, and a brief overview of the various actions that provide software developers what they need, the next topic snippet you should review describes various tools in the market that provide version control. So that topic snippet is called Software Development Repositories. And this concludes the topic snippet on version control.